Hello everyone, I hope you are doing very well. In this video, I'm going to demonstrate how hierarchical multiple regression analysis can be done in EQS. So this is my dataset that I use for simple and multiple regression as well as stepwise multiple regression. You can see that we have the same variables here. On the right hand side, we have calculated the scores for interpersonal conflict, role conflict, positive affect, negative affect, job performance, and job satisfaction. Now, based on hierarchical multiple regression analysis, I would like to see how these four predictors, including interpersonal conflict, role conflict, positive affect, and negative affect, can predict job performance. So to perform a hierarchical multiple regression analysis, you need to click on the analysis menu and then from here regressions and then hierarchical multiple regression analysis. And it's quite easy actually to perform hierarchical multiple regression. You just need to define your dependent or outcome variable, and also you have to add your predictor variables in this list. But the difference between hierarchical multiple regression analysis and stepwise multiple regression analysis is that variables are entered into the hierarchical model based on their order in this list. So if I select IC, RC, PA, and NA as the predictors and I click on this button, then in the first run of the multiple regression analysis, there will be no predictors in the model. Then in the second run, IC will be added to the model. In the third run, RC will be added in the model. In the fourth run, PA will be added in the model, and in the last run, NA will be added to the model. So similar to other types of regression analysis, you can click here and save regression estimates and residuals in the data set. Let me click on this button and see the result. Okay, as you can see in the first step, there will be no predictors in the model. That's why you can see a F statistic of 0 and the p-value of 1. You can also see the Durbin-Watson statistic for this particular model, as well as the unstandardized patch coefficient for the intercept. In the second step, IC, which is the first variable in the predictor variables list, is added to the model, and you can see that based on analysis of variance, the F statistic will be 5.759, and it is statistically significant. And you can see that this predictor, interpersonal conflict, can only explain a very small amount of the variation in job performance. You can also see the unstandardized and the standardized patch coefficient for interpersonal conflict, as well as the T statistic and the p-value, which indicate that IC is a significant predictor of job performance. Then we have the next predictor, which is role conflict. So role conflict in step 3 is added to the model. You can see the new F statistic and the p-value. You can also see the new R square, which is 0.0111, or in fact, these two predictors together predict only 1.11% of the variation in job performance. In the next table, you can see the unstandardized and the standardized patch coefficients, and both of them are in fact statistically significant. Then in step 4, positive affect is added to the model. You can see the new F statistic and its corresponding p-value. You can see the new R square value here. So all the three predictors together can explain 9.85% of the variation in job performance. And you can also see the patch coefficients in this table. So these are the unstandardized patch coefficients and the standardized patch coefficients. Please note that IC is not a significant predictor of job performance. And then in the last run, you can see that negative affect is added to the model. This is the new F statistic and its corresponding p-value. All of these four predictors can predict 10.47% of the variation in job performance, and you can see the pass coefficients here. So on the standardized pass coefficients and the standardized pass coefficients. And as I mentioned earlier, interpersonal conflict is still not a significant predictor of job performance. So let me just minimize this. Here you can see the predicted values for job performance and the residuals. So these residuals are in fact the difference between the observed values for job performance and the predicted values. So if you want, you can create a scatter plot of predicted values versus residuals by clicking on this button, selecting the predicted values as well as the residuals, and you can have this scatter plot. You can save it and use it in your thesis or paper. So it was all about hierarchical multiple regression analysis. The only difference with a stepwise multiple regression analysis was that in a stepwise regression analysis, as I mentioned in the previous video, variables are entered or dropped from the model based on the criteria that are defined here. And in hierarchical multiple regression analysis, there will be no criteria, and the only criteria that is considered by the software is the order of the variables that are listed in the independent variables list. Okay, thank you very much for watching, and I hope you enjoyed this video on hierarchical multiple regression analysis in EQS.